So welcome back, everybody. I know it's been a little while since I've done videos, but I'm going to do a series of short videos on some different things that I've explored with my printer, my 3D printer. I'm just enthralled with being able to design a solution to a problem and print it out and have a sort of a new device, a new product on my shelf. So I'm a woodworker, and this is what they call a bench cookie. It's made by a company called Rockler, and this is intended to sit on the bench, and you have a panel or something that you have on top of this that you're refinishing or you're sanding, and to keep it from being scratched by a hard surface on the bottom, this just kind of protects it and keeps you from damaging the back side of it. Rockler's a great company, love their product. Works really well, but hey, I own a 3D printer, why not? I went online and I found the inserts for these discs, and they're just double sticky discs that you can see here is one of them. And I made sure that it's not exactly the same size. I made sure that when I'm designing it to this size, but my intention is to make and print some of these guys. And this is what it looks like. So this is straight off the printer, and it actually fits really well. I've already tested it with the insert here, and the insert actually is recessed just the right amount that it just sits up proud of the surface there. And it's extremely straightforward. This is actually, there's only two features in this. Just a sketch and a revolve, and that's it. And then you 3D print it. And I printed it on my bamboo printer, so you can actually tell this is sort of the top surface. This is the bottom. It's a little bit rougher because of the supports that are required to print it, but since it gets covered with this guy, it really doesn't matter as long as it's the right depth. So let me pull this up in CAD and show you exactly how I got here and how simple it is to get to this point, and we'll go from there. But before I do, I want to real quick, as you're doing these kind of projects, you really need a caliper. Now this is a nice one. It's a Mitsutoi, if I'm pronouncing that right. It's solar, so I don't have to worry about batteries, and it's digital to where it stays, I mean, you can read it directly. Goes in inches and millimeters, and it's a 6-inch. Given the size of my printer, this is pretty much all I need it for. And it works absolutely fabulous. So if you do get into this and want to, especially if you're going to replicate something that exists and need to know dimensions off of it, one of these guys is extremely helpful. So I think I might have bought this on Amazon. If not, I'll put a link to something similar in the description as well, in case you do want to buy something like that. And the nice thing again is it's in millimeters. Everything else thinks in millimeters. Your printer thinks in millimeters. You can use Fusion in millimeters, so you're all consistent with the dimensions, the units. So let me jump over to CAD and walk you through exactly how easy it is to make one of these guys. So this is the bench cookie. And it's fairly simple. As I mentioned, it's only two features. It's the profile, and that profile actually spun around an axis. About as simple as you can get. I'll redraw it so you can see it, but just to show you the profile, it's very simple. This is the recess that the foam piece sits into, and this is the on either side, and of course this is the outer edge that has that radius curve on it. So very, very simple, just takes a little bit of time to get it drawn in, and I'll talk about the process of doing it, but this is where the power of Fusion comes from, being able to create a sketch, and then you're going to either add or subtract or push or pull that sketch into the shape that you want. So let me get out of that. I'll create a new one, and let me just start that process all over again. So I'm going to create a sketch on this plane, and first thing I'm going to do, since this is a rotated, I'm going to create a line that is a center line, and I'm just going to draw it in here and say done. And then I'm going to go to Sketch Constraints, and I can't find it. There's my collinear. And make that line collinear with the axis. So now that center line is collinear with the axis of the X, call it the XY plane. And just an aside here, there are hundreds of videos about how to do Fusion 360 and all these tips and tricks. I won't go into those. If you guys want me to do more on that, I can just put some notes in the comments so I can respond to it. But one of the most powerful things is the constraints. If there's anything you can learn in Fusion 360, first learn how to do the constraints as you're doing as you're drawing something. And I'll show you some of those items as we go through. So I'm just going to start drawing a little bit here. Now it automatically picks up some constraints. So if you look here, see it put the X there, and it's going to basically put a constraint of locking the starting point onto my axis. So that's already one constraint. And actually you see that little bracket there that's right there? That's telling the system it wants it to be 90 degrees to that. So that's a second constraint that you can either apply manually or it's automatic. So I'm just going to go through and draw just the rough shape of what I want the top to be. I don't want it to do the constraints. I like doing the constraints myself. I'm also going to insert an arc, and I'm going to go a center point arc. I'm going to put the center there. Notice that it's a box around it, so it's going to lock the center to that. I'm going to put the end of it there, and I'm just going to drop the end out here someplace. Okay? So here's where constraints are powerful. This is the vertical and horizontal constraint. I want this guy to be horizontal, and I want this guy to be vertical. It figures out that if it's mostly vertical, it's going to go vertical. If it's mostly horizontal, it's going to go horizontal. So now this one already has a constraint that it's at 90 degrees. I can change that, but I just want to leave it. So that's basically the shape that I want. Now I'm going to put one more line in here, and this is going to be a construction line. Again, I'm just going to draw it in here somewhere because I like doing my constraints myself, and make this guy collinear with this. So I've just put a construction line, it's different than a center line, a construction line, because I'm going to mirror these three lines across this. And it's going to make it exactly, all those little boxes you see, it's saying make those to be symmetric across that center line. I'm going to drag my box here, and it's going to lock it there. And now I have my basic shape. So it's all locked in. This is the profile. I just need to throw in some dimensions. So now Fusions is smart enough, when you click a dimension and click a center line, it's going to think you're going to spin it about an axis. So it's actually drawing the dimension to the other side as if you were spinning it. So it's giving you the diameter. I forget what the diameter of this is. So that's that dimension. I'm going to put a dimension from the center line here to, and I'm going to force it to pick the tangent of the outside of this guy and put that one, I'm going to call that one 36, just to push it out there. And this guy to be, let's call it 36 as well, just for that. And across these two, this dimension, and across these two, this dimension. And that locks everything in place. You can tell when it's completely constrained as all the lines turn black and they're blue, which means that the dimensions are completely constraining this piece. So if I'm not mistaken, this dimension here, I want to say it's 74. But again, since this is going to be half, I'm just going to say divided by 2, so it's 37. I want to say this is 60, and which is what I tried to put in earlier. This guy, let's make the inside one, I want to say it's 12 on the inside, and then the outside I think is 20. So I think that's roughly the numbers that I had in there before, and that's it. So I've got this shape that now when I spin it, I'm going to do a revolve, it turns that shape. You can see there's the profile. It spins the shape around it, creating the disc. And that is exactly what this is, just I didn't get the exact dimensions plugged in the first time, but I can come back in here at any point and edit my dimensions and make it to be whatever I need, so test it out, etc. And that's as simple as it is. I mean, Fusion, it's about as straightforward of CAD system as you can get. So I pulled in the Bench Cookie into Bamboo Studio, and there's one setting you'd absolutely have to have, because if you remember, there's a recess on the back side, and that is a very large span that a 3D printer can't span that without having some supports in it. So you will have to turn on supports in this. So if you go to supports to make sure that you've enabled supports, I've made it a normal support instead of a tree support. In this case, it's better because it's just a large flat area. Tree supports are good if you've got some different shapes. And I've unchecked remove small overhangs. And when you slice this, again, this is going to be printed in PLA. When you slice this, then you're going to see, do line types, there's the support back there. And that's going to hold up the bottom side as it's printing through. So if you just drop this through, you see there's the support, and then there's the first layer, and then there's final layer. So it's important to have that support. This support actually, every time I've printed it, the support actually sticks to the plate, and it doesn't stick to the part, and the part comes off. And you got to remember, it doesn't need to be really perfect and smooth, because you're going to stick a little sticker with the foam on top of that anyway. So that's the one thing you definitely want to have in there. I did dial up, just so you can see, for strength. I picked a strength, the 0.2 millimeter strength setting there. Gives it more wall and more top and bottom surface thicknesses of solid. Besides those two, it's straight out of the box, letting it print as is. I print them in sets of 4. The foam pads that, again, the link is in the description, come in a package of 16, which gives you enough to do 2 sets of 4. Again, I'll leave everything, all the links in the description, and if you have any questions or comments, just please leave them in the comments and I'll get back to them as soon as possible. Thank you and enjoy.